I'd like to now introduce today's speaker, Scott McCarley, Senior Director of Solution Management at ThingWorx. Over to you, Scott.
All right. Well, good morning, wherever you are. My name is Scott McCarley. I'm Senior Director of Solution Management at ThingWorx. I'm part of our product management team. Today's webcast, we're going to talk about ThingWorx Foundation. And maybe just to kick it off, I'd mention that the demand to build new connected applications is at an unprecedented high. Development teams, as you know, are being stretched thin and asked to learn IoT technology as quickly as possible. The development teams and businesses that can quickly bring to market secure, scalable solutions with compelling end-user features will be the ones, the products and companies that are established as leaders for years to come. So in this webcast, we'll look at how ThingWorx Foundation and PTC's IoT suite can equip you with the necessary tools to achieve that goal, to enable your product or company to be the leader. So with that, let me just introduce ThingWorx and our PTC's technology platform group. So we're a business unit of PTC. We have about 800 or over 800 employees dedicated to IoT. We have market-leading customers across every segment, whether that's in medical devices, aerospace and defense, energy, you name it, right? So in every market, people are using our technology to build connected solutions to enable devices to connect, communicate to the internet, and deliver high-value applications. PTC has also been investing in this space for quite some time, and our technology is born out of huge investments, both through acquisition and through internal development. So you can see a figure here, 700 million. I just want to flash that figure up so that you appreciate we're trying to bring technology to bear or to market that you can leverage, right? So that it can be the underpinnings of your solution. And you can see the amount of investment and effort that has gone into the technology we're discussing here. So it's truly market-leading technology, and we're very proud of our customers. So with that, let me just introduce at a very high level what is ThingWorx. So ThingWorx is the centerpiece of PTC's IoT platform. It provides capabilities to enable innovators to rapidly build and deploy game-changing connected solutions. ThingWorx Foundation enables the development of secure, scalable solutions, ones that are simple to create, or with ThingWorx, it becomes simple to create. You can accelerate the time to market of your solution, and we're going to enable you to make end-user experiences more compelling. Kind of hitting those same themes at a very high level very quickly. ThingWorx is going to help you build your IoT solution faster than you are or you're able to do without the usage of it. It's not only going to enable you to deliver it more fast, though, it's going to enable you to do things that you couldn't do without the use of ThingWorx. So we're going to enable you to become a smarter developer or enable a greater portion of your team to do things that they weren't able to do before, things like delivering augmented reality. So we want to make you smarter developers and a smarter development team. We're also going to enable your solutions to be built for the enterprise. And by that I mean they're going to be secure. They're going to be scalable, right? So for future growth. But they're also going to be flexible. So you're going to need to maintain these solutions as your requirements change over time. And we're going to put in place an infrastructure that's going to be well position you to adapt to change that's going to come. So this wouldn't be or it's hard to have an IoT webinar without taking a step back and appreciating the size of the opportunity. I love the statement, this is IoT represents the economic opportunity of a lifetime, because I think it just frames up the excitement in the real world, or the very real opportunity that we have. So companies like McKinsey have estimated that there's $6.2 trillion in new economic value add that will be created by IoT. I also like this additional figure from McKinsey. So this 6.2 trillion, right? In order to realize it, there's going to be a tremendous amount of new application development. And I'm sure everyone on the phone realizes it. This software doesn't exist today that's going to deliver that 6.2 trillion in new economic value opportunity. But all of those applications, it's not just their ability to now connect to a device in the field or to pull sensor information from the real world. It's the ability to combine that information with other system information, right? So, this 40% figure shows that much of the value is going to be created by taking real-world connected information and combining it with information that exists today in other systems, or perhaps combining it with information from other connected devices. So, that's an important, thing to keep in mind as you build your solutions. It's not just a simple, pulling information from a device. It's finding and combining that with other system information. I think this slide kind of represents that well, or a couple of those points very well. There's a lot of new applications that are going to be delivered. They're going to need to combine information, real-time information from assets with existing information from systems or potentially even other connected assets, and together they're going to deliver on that value. So here, we could see an enterprise. They obviously have connected devices, assets in the field. They're receiving that information, but the real value isn't just in exposing new capabilities at the product side or the connected device side. It's combining that information with existing system information. So in the service world, if you call into a service professional, they're able to, understand what their CRM system says about you when you've called in, but they're also able to combine that with information from the product to understand its real-world operating, real-world operating situation. Is it exposing an error? Is it, what's going on the piece of equipment? So the combination of that is really deriving the value. In addition, you get your multitude of applications in the service, whether it's being able to do predictive service, maintenance scheduling, ability to remotely service it. So there's a tremendous amount of applications, but I want to demonstrate that it's combining it with other applications. In sales, again, through CRM, you'd be able to understand, which customers should I be calling, who needs new equipment. Perhaps a piece of equipment can say I'm being used at 100%, or I'm being utilized at 100% capacity. And that would be a customer that you would probably want to follow up with about a potential additional sales opportunity. In operations, the most real world or the largest opportunity we see today, and I think the market sees, is in the connected manufacturing. So actually connecting up all the equipment within a manufacturing facility to better understand and better improve OEE, sort of the output and efficiency of that factory and producing new products. So there's use cases around each of these different areas within an enterprise, and this is just an example to show that there's a tremendous amount of applications that are going to need to be built to deliver on that value. They're going to need to be combining information from other systems, and it's really going to be impacting everyone, right? It's going to be transforming not just a single individual within a company or just the product user or device user, someone standing in front of it. It's going to hit a multitude of people, and certainly everyone who works within an enterprise. So what is it like to what are the challenges that solution development is having? What is it like to be a solution developer today? Well, some of the challenges, the first challenge is simply the amount of demand for new application development, right? So people aren't just being asked to deliver one application, they're being asked to deliver many applications, and that puts a lot of stress on the system or on the solution developer. The actual software developers also, they're spending a lot of time writing, rewriting, testing, and retesting commodity portions of an IoT solution, what you would typically call the plumbing. And that's something that an IoT platform can quickly deliver on as well, right? So why would you want to deliver on the plumbing? The people working on a project, the software developers, may not possess the experience across all of the different elements of the stack, and I think that's most people would recognize that within their team, that they have people who either elements of the stack that no one's very familiar with, or certainly very few people are familiar with, and they're being asked to do things that they're not that comfortable with. Ultimately, the team working quickly on a project and on multiple application projects is unsure about the correct solution structure, the architecture. People are being asked to quickly stand up solutions with maybe even vague requirements on occasion, and they're doing so not really fully understanding what is the right architecture, and that can have a lot of downstream negative implications. They're also being asked to enable or deliver new exciting technologies like augmented reality and put these into their applications when they're already unable to meet just a simple their plans to deliver applications as they were originally required to do, and now they're just being asked to even do more, right? So every time there's a new innovation or a new enabling technology, it becomes hard. And as everyone knows, these are not off-the-shelf use cases that they're being asked to execute on. So these are things that they have to deliver, have to build the business logic for. So to drop down a level from here and to look at, well, maybe more of a day in the life perspective about application development. So here we have a device that's connected via cellular connectivity, and it's communicating. So an application development team or a team would need to have someone that's familiar with devices and making sure that the connectivity or it's communicating correctly off the device. They'll need to have someone on staff who understands the communication side, so being able to receive that information, process it, and store it. So from a cloud perspective, in this case, once they've ensured they're receiving information from the device, storing it correctly in the cloud, then they're going to need to architect a data model. They're going to need to write services so that they can extract information or data correctly, perhaps put new information into the data model. They're going to be coding the business logic based on the needs of the application. They're going to need to do things like write the user permissions, who has access, who should be using this this application, what are the different things that different users can do, and ultimately then they're going to need to design and build a web interface. And once they've done this, they've delivered their first fixed application. So this is traditionally with sort of do-it-yourself projects, what it's like to go through. But as soon as a company is near to completing their first application, typically what happens is someone comes along with another device or another application that needs to be built. So in this case, maybe these new devices are connected, need to connect via gateway. So perhaps again, we're in some sort of industrial setting here, and we have multiple pieces of equipment, different equipment, that needs to communicate into a gateway, and that gateway is to transfer the information to some repository, some data management repository. And this could be sensitive information about the operation of the equipment. So this could be important. Let's say it's an oil and gas situation where there's a significant amount of business, and they're very concerned about the security. So now we need to involve people who are really familiar with security professionals. So they're going to need to be paying attention to encryption and device security. The team recognizes that some of the data model from the past application they built would be applicable here, but it needs to be changed somewhat, so they'll re-architect that data model so that it can work for both applications. And this new application, perhaps we described coming out of the oil and gas field, needs to really integrate with an ERP system, for example. So someone's going to have to build that integration. They're going to have to build new alarms that are particular to this application. Say if this threshold vibration occurs on a piece of equipment, throw an alarm. They're also, however, per the needs of this application, they might have a collaboration environment where the different service professionals need to be working together or be working with other people in the operations of the equipment. And then ultimately the request here might be for a mobile app, right? So these are field deployed people. So we've established this second application But again, by the time they're getting near to that, maybe a third application comes along, and in this application, there are a new set of requirements that don't really match well with what they've delivered in the past. Perhaps this piece of equipment needs to has intermittent connectivity, so it's going to need to cache information, and maybe it's storing so much information that it actually needs to process some of it locally and just transfer some of the information across across the internet. Perhaps there's millions of these too, or thousands or hundreds of thousands. So there's real scalability issues within this application. And again, they recognize that, well, this is going to force them to change some of the data model in the past, which they want to preserve because they're trying to, make an efficient management model, but they end up having to redo it. Requirements out of this one, it's not just pulling information from other systems, but it's sharing out information. So they want to make sure everything is API enabled. Again, they're defining these new events that are particular to this scenario, this piece of equipment. And perhaps there's a customer-facing angle. So not just user permissions anymore, but new customer permissions that, is for a wide audience of people. And they're going to have to define a brand new interface that's customer-facing. So all of this is being done and becomes incredibly complex. And some of the negative consequences are, one, it's obviously can be extremely inefficient, right? It's complex and inefficient in that they're not, their reuse is difficult to come by. They keep redoing portions of the application. There is people, again, writing at a very low-level plumbing. The ultimate, the results are things get delivered in a long time frame, and they're not just hard to build, but they're difficult to maintain and evolve. Right? These are fixed applications ultimately. The total cost of ownership is very high. So not just in terms of the solution development, the solution maintenance, but perhaps even in the cloud infrastructure, right? So there could be very high cost of ownership, and ultimately these sort of do-it-yourself applications, or in this instance, as we described, it's unproven scalability and security, right, which is a huge concern for organizations. And frankly, focusing in this manner as they do is a barrier to innovation. It's taking a long time, sucking up a lot of resources on repetitive or on sort of low-level tasks, and it's a barrier to them delivering new business functionality. So this is the role of an IoT platform, is to simplify this solution delivery. So an IoT platform, should provide edge software to securely connect devices and communicate that machine and sensor data into the cloud, or even to an on-premise solution. It'd include a device cloud data management layer that should collect that information and process it. It's going to include application enablement, and it's going to support the device, or application enablement that will not only support the device management layer, which allows you to remotely sort of monitor, manage, and service connected devices, but that application enablement layer should also deliver rapid application development capabilities to enable you to build new IoT applications that are particular to your devices, your connected products in the market, and to your or your customers' internal business processes, right? The things that need to be custom designed. So an IoT platform is going to simplify solution delivery. To take a step back, though, it's not only going to simplify solution delivery, it's going to enable some things that maybe some pretty sophisticated things from an infrastructure perspective. So here we take a look at a typical IoT solution that people build, right? So you have some technology at the edge that is collecting information from a device and sending it to the cloud for typical processing, analyzation, and delivering the business logic, represented by all these color boxes. And we see just one box at the edge, which is that collecting information. But for some devices, such as this piece of equipment here, we can see that it's communicating a tremendous amount of information, or has a lot of information that can roll off of it from sensors. So here we see 50,000 data points per second being created from this piece of equipment, and that's about the operation of that equipment. So that's critical information. Well, we can't send 50,000 data points per second to the cloud. That's just simply not feasible. So what we would need to do in this scenario to capture the value from that information is that we could process it locally, right? So at the edge, if we move some of those capability sets from the cloud to the edge, here we can see we can analyze that information, process it, and distill it into a certain amount of alerts. Right? So if we see through either analytics or through thresholds, things going on based on the information flowing off the machine, we can flag an alert and send the alerts to the cloud. Right? So this is a much better application design for this piece of equipment. To take that one step further, you can have functionality not just at the edge, but also, and let me say at the edge, either embedded into the piece of equipment or on a gateway, a tethered gateway to that piece of equipment. But you can also have capabilities in the fog, so at some point between the cloud and the edge, maybe a local site in this example, right? So you might actually have an operations site where you have multiple pieces of equipment, each piece of equipment doing some identification or analyzation of it and communicating to a processing point, a sort of a further up processing point, perhaps containing all of the equipment at that site, or for a different audience that might need that information. And then further information can be communicated up to the cloud where a different set of analysis could occur, and that could potentially be across all sites, multitude of sites across the world. So the purpose of an IoT platform is not just to help you, relieve you of the plumbing work you were planning to do, but to put in place an architecture and infrastructure that is perhaps far beyond what you might have originally been shooting for, but is appropriate for the needs of your solutions, or as your solutions evolve, will become appropriate. So, and I think there's no reason that any individual or individual team would want to deal with this complexity. So ThingWorx solves that scenario very well with the most complete end-to-end IoT platform capabilities in the market. ThingWorx delivers a tremendous amount of capabilities and unique capabilities in the market. We're going to talk through each of these elements of the stack, but first I wanted to talk to you about the Thing model. And that's something really important for ThingWorx Foundation and for ThingWorx in general and our IoT platform. So the Thing model is built using Foundation's visual modeling environment, and it describes a digital representation of your physical assets and their relationship to relevant data across other systems and functions. So this, the model that we create is going to be the cornerstone for your application, as well as really the cornerstone for our whole IoT platform. So the result of building models is that you're going to get really high application development velocity. You're going to get highly maintainable and efficient application development, and we're going to increase the amount of code reuse that occurs in your organization. So for every, let me click this out just to show that that model is permeating every element of the stack here. So when you create a Thing model, you're going to dynamically generate a REST API for all of the things in your world. And that's going to enable rapid and consistent development across all of your IoT solutions and sort of provide a single window and one uniformly shared view into that thing. it's going to enforce a single data model for all of your applications. And as I mentioned, it's going to connect all of the tools in the PTC IoT suite. So here I'm showing just what I've highlighted here is just ThingWorx Foundation. But beyond that, the model is going to connect the entire suite. So, shown in green is Foundation, but shown in gray is the entire suite. So including analytics, device management, augmented reality, and industrial connectivity. Each of these leverages the model so that you can quickly leverage them to build better solutions. All right, now I'm going to try and go through some of these in a little bit more detail, or I'll go through all of the sort of major areas of the stack in some more detail. So ThingWorx Foundation securely connects to any device over any network via short haul, and that could be Bluetooth or Zigbee or some low-powered wide area network, or long haul communications, meaning wired or cellular methods. ThingWorx Foundation has SDKs that can allow customers to create custom agents that can be deployed embedded into a device or in a gateway. It also provides a pre-built agent called Edge Microserver that can be dropped in and run in a Windows or Linux environment on a gateway. So that's going to enable you to very quickly communicate either with a device or with multiple devices through a gateway. It supports emerging standards for protocols like MQTT, REST. It delivers, and I think this is very important, it delivers continuous bidirectional connectivity between the devices, the equipment, and the ThingWorx server. Right? So it's not just receiving information from the server or communicating it up. It's enabling a bidirectional communication, a very secure bidirectional communication. One of the things that I glossed over here is the presence of Kepware. So Kepware itself is going to deliver the connectivity to all of the industrial equipment in your environment. And it has over 150, supports over 150 proprietary protocols or device protocols. So it's a very market-leading mechanism for communicating with industrial equipment to make it very easy for you to bidirectionally communicate from a piece of equipment to the ThingWorx server. Additionally, this edge layer is going to enable distributed real-time computing capabilities, right? So it's going to deliver that edge solution stack that we talked about a little bit earlier. And that can eliminate issues with latency, cost, or security, and really create the right architecture for your scenario. Or, deliver you this sort of future-proofing. By having all of this capabilities at your disposal, you'll be ready for change, whether that's in what types of protocol communications you use, your logic you need to run at the edge, or your growth as you encompass and maybe build in additional solutions or additional devices into the future. At what we have called the sort of device cloud layer, ThingWorx supports an open platform, what we call an open platform and anywhere deployment strategy. So ThingWorx Foundation will allow you to more fully leverage. So if you're already have relationships and investments, cloud investments with Amazon Web Services, Azure, or GE Predix, we can enable you to leverage that investment and use those components and mix and match maybe your preferred combination of components from cloud providers and ThingWorx. So we're going to work with those. We're going to deliver the right capabilities at the right place. So storage options ranging from embedded at a machine to on-premise solutions or in public or private clouds. We're going to deploy enterprise-ready architecture so that you can support sharding, federation, geo-distribution across platform instances for scale and security. So those are some kind of complex topics, but I think as you deploy solutions at really enterprise level, you need to think about those topics of federation and sharding and geodistribution. We're going to provide a high volume, high velocity data ingestion so that you can support millions of devices with hundreds of thousands of transactions per second. So at the application enablement layer, here's where you would use or visually model the things in your world. So that's going to increase your development velocity. You can leverage pre-built services for data ingestions or pulling data intelligently, security. It's both for application development and runtime support. We're going to enable you to easily store, search, correlate, analyze both unstructured data, or I should say, sort of three types of data: unstructured data from people, structured data from systems, time series data from things. So being able to correlate all of that and intelligently manage it. Through our drag and drop builder, you're going to build rich interactive applications very easily. So creating dashboards, collaborative workspaces, mobile interfaces, without the need for coding. So we're going to make it very easy to build UIs or for members of your team or your extended team. And we're going to deliver an extremely secure sort of infrastructure environment so that you can specify a very granular security model that enables data isolation and service execution. ThingWorx utilities. So this is enabled again by the Thing model. This is not part of Foundation. So the next items I'm going to talk about very briefly, not necessarily part of Foundation, but they're enabled by it and work seamlessly with it, all because of the Thing model. So ThingWorx utilities, really turnkey solutions for device management. So with it, not only can you enable business analysts or administrators to manage devices, but your developers could embed device management capabilities into other applications. So you might have other software applications that need to embed this capability set. You can do so. With it, you can efficiently and reliably distribute digital content, such as software updates, upgrade, patches, to your end devices or connected devices without need for any programming. We're going to enable you to create, schedule, manage the deployment of any content packages to those products. We're going to enable your business analysts or people managing your devices to design and implement workflows, right? So they could use a drag and drop interface to create business processes to manage their devices, products, and systems. So there's some capability set there that they can become self-sufficient and manage the business logic or the business processes associated with device management without coming back to the software development team for additional work. So ThingWorx Analytics, again, based on that model and the connectivity that Foundation is providing, ThingWorx Analytics is going to enable developers to easily add analytics into the solutions they build. And that could include anomaly detection, which looking at real-time anomalies, predicting future outcomes, and this is all to be done, without the need for expertise from a data scientist. So again, enabling your staff, which may not include a data scientist, to deliver rich analytics or very sophisticated analytics. Augmented reality is really exciting. Personally, I'm blown away by it. We've been very excited here, at PTC and within ThingWorx about augmented reality. It's really for me it's just made IoT information so accessible, in such a manner that you can really imagine it being adopted by people who previously may never have, thought, or who I never envisioned, digesting that IoT information, and maybe them doing it now through augmented reality. And also for others, it just becomes an incredibly efficient manner for them to digest information. For example, if you were ever working on a piece of equipment, to be able to have your hands free and being able to just look at a piece of equipment, see the digital information, overlaid on top of it, it is really mind expanding. And I encourage everyone to think through how it can be best be leveraged inside your connected device. But leveraging that same model now that we have inside of that we created with the Thing model, you can quickly create an augmented reality experience using Vuforia Studio through a drag and drop manner, right? So just based on that model, you can build an augmented reality UI quite easily. So you don't need to have AR experience. So it can be used smartphones or wearable devices as well. Right? So we'll just end it there, but it's a very exciting piece. So again, this is a look at the entire IoT suite. And we see foundation in the center, but everything is impacted and powered by the Thing model. And the Thing model is ultimately, I think, a cornerstone of good development practices. So having that sort of single view into a thing, the creation of APIs, ensuring of a data model, a consistent data model across all of your solutions. As we look to wrap up some of the content here, I thought one, sort of taking a step back and looking at ThingWorx and talking about what it might bring to your company or to your development team. ThingWorx is going to speed and democratize your application development by enabling developers, designers, business analysts, security admins, and even end users to collaboratively build, maintain, and evolve the rich applications, business logic, dashboards, user interfaces that you create and deliver, right? So ThingWorx becomes a mechanism for not just speeding your software development team's efforts, not just enabling them to do their jobs better, but it broadens your application development workforce, right? So we're going to collaboratively enable the designer to work with them, but we're also going to enable the business analysts, the security admin, so everybody to get involved, and help build the application and to improve everybody's capabilities as they do so. So let me just end it with a quick customer example. I just pulled this one out. There's is infinite, nearly infinite, or at least hundreds and hundreds, almost thousands of examples I could cite here. But this ThingWorx customer, leapt to mind, and it really did, because with a reasonably small development team, they delivered a fantastic solution that leveraged a lot of the IoT stack in a working with a diverse array of equipment. It enabled edge processing and analytics. It created a solution that could be delivered on-premise or in cloud, and really with a feature-rich and an attractive UI, and you can see the UI here. So this is Depsys, and they built really a grid solution, and it allows customers to understand what is happening in a low-voltage network. So monitoring the critical points of a grid, the understanding the voltage within the grid, informing of issues and alerting on voltage deviations or if there's excess current. It enables the utility or the operator of the network or to really have management control of decentralized energy sources as well. So if they're injecting power, they could manage that based on the what they're seeing in terms of within the grid. So a much more optimal energy flow in their network. So really great capabilities. But one of the reasons that makes it a nice example here is that everything is not done centrally at the server, right? But they provide a system that enables edge, calculations and analysis, right, inside of these base modules they have throughout the grid network that measure real time, and they push information to the server at a configurable moments, meaning, it could be minutes, whatever makes right for the utility working or the operator of the network. And that's what's visualized from the central point, but they have all that intelligence at the edge. For many utilities, they need on-premise solutions, so this could be deployed on-premise within the network of the grid operator or the grid owner, or it could be deployed in the cloud inside of DEPSIS, cloud operations center or wherever they're using for their Grid-Eye product. So it's really a cool solution, and I just wanted to call it out as a real-world solution that's doing obviously very important high-value work within the low voltage grid. So this is within Europe. They're working with utilities there. But with a flexible architecture that enables them to meet their individual utility needs, and really these great high value application side. So with that, I thought I'd open it up to, or maybe invite Brittany back in and open it up for some questions.
Great, thanks so much, Scott. Again, so if you'd like to ask Scott a question, please use the question box located on the left side of your control panel. We do already have a few that have come through already, so we'll go ahead and get started. First question, does the platform support specialized industry-specific protocol standards such as MBus or OPC?
Yeah, okay. So yes, this is the answer. We have out-of-the-box support for a variety of industrial automation protocols, and that's through KEP Server X from Kepware. That includes OPC and lots of other industry standards, as well as numerous drivers for proprietary protocols. Again, as I mentioned, Kepware provides a library of over 150 drivers to enable control and access to real-time data from industrial equipment. Outside of Kepware, ThingWorx also has a set of connectivity libraries that are used for other industry protocols such as MQTT and OBD2. Yeah, I think that answers it.
Great, thanks, Scott. So the next question is kind of a multi-part question. They asked, how does the IoT software platform support scaling from connecting a few IoT devices to connecting thousands or even tens of thousands? And what is the maximum number of supported devices for the platform?
Okay. So ThingWorx provides horizontal or scaling at different layers in the architectural stack. At the connectivity layer, we provide connection servers, and these serve two purposes. The first is to scale the number of connections, and in theory, this is an infinite. You could have an infinite number of concurrent connections, right? So an infinite number of devices connected, and that's limited only by the hardware and bandwidth. I mentioned a secondary purpose, and that's really just to serve as an abstraction layer, so that it's not just ThingWorx maybe communicating device information in, but you could use other agents from other vendors or standard protocols as well. But to answer the question, it's really given the architectural and horizontal scaling capabilities of ThingWorx, it's really just limited by the hardware and bandwidth.
Great, thank you. Next question. Does the software platform include an API library for developers, such as, I believe it's RESTful Web Services, Java, .NET, iOS, Android, and if so, which ones?
Let's see. So ThingWorx includes a full set of REST APIs for both design time and runtime. I talked a little bit about that earlier on. So the ThingWorx, as you define things, there's a patent on this from ThingWorx. We dynamically create REST APIs based on the model you're creating. So as you add new things, those are dynamically represented in the REST API. But in addition to platform APIs, there are SDKs that can be used to consume the platform APIs. So let's see, we have native SDKs for .NET, Java, C, Android, iOS. There's also an Angular SDK for user interfaces, so that if you wanted to, create your own UIs, not using our mashup builder, you could do so as well.
Great, thank you.
Yeah.
So we have one other kind of multi-part question that's come through. How long does it typically take for a client to get up and running on the platform, and how are they onboarded into the solution? When do they begin to move beyond piloting and realize true value from the solution?
Okay, that's a good question. So offhand I'd say, clients typically go through an initial proof of concept phase, and this can take weeks or maybe even 1 or 2 months depending on the scope. This is just a typical engagement. Every scenario is different, as I'm sure you can appreciate, but there's this initial short proof of concept phase between weeks and just a couple months, and then people, based on that proof of concept, harden the solution and typically can begin to have a real receiving value from a deployed solution within a quarter, right? So, and again, this is dependent on the use case and the scenario, but what I want to demonstrate is that you can very quickly be deploying, moving from proof of concept to a system that is, delivering value. But from there, again, we recognize that the best, or a typical practice, and I would argue for best practice, is to continue to iterate on that solution, right? So you've now deployed something that's demonstrating real value, but you want to continue to iterate on it. So typically what happens is after deploying a solution and watching it receive or deliver real value, customers will continue to iterate on top of it, right? And so add new capabilities to it. And maybe extending the solution with analytics, or adding augmented reality as a follow-on capability. So I think the best scenario is you want to prove that what you can do as quickly as possible, deliver something to market as quickly as possible that shows real value, and then continue to enhance it with new capabilities as you go.
Great, thank you. So actually, to kind of piggyback on that, Scott, we had a question come through that just asked to kind of elaborate on the analytics capabilities. I did just want to mention we do have a webcast specific to ThingWorx Analytics on the resources page under webinars on ThingWorx.com, but not sure if you want to just address that briefly, Scott.
Yeah, I think it's probably best. I'd encourage you to look at that webcast rather than me, very quickly painting a picture. I'd encourage you to please take a look at that. And there are other resources on the web, but that's a great one that Brittany mentioned. Perfect.
Great. Thanks, Scott. So another question, someone asked, are there any limits to the amount of objects or data that can be included on a mashup?
That's a good, an interesting question, a limit on the objects or data that could be included in the mashup. I'm going to take that as a note, and I'm sure Brittany will have these as a, these questions, and we'll follow up with that person. I'm offhand not familiar with any limitations, but I want to make sure that we respond to that person with the right answer. So we'll definitely get right back to that person.
Great, thanks, Scott. So let's see. Another question that's come through is, in terms of street lighting intersecting with IoT, does ThingWorx have any experience or case studies that we can speak to in this field of work with Wi-Fi, utility metering, or public safety? Is that something you can speak to, Scott?
Yeah, what was that first, Brittany? I just didn't hear the word street lighting, did you say?
Yeah, street lighting and intersecting with IoT.
Yeah, so we've definitely been involved in a number of street lighting projects, and are right now, as you're familiar, we're providing a ThingWorx platform, and our partners and customers take our platform into markets. And so we're working with a few different businesses inside of and around street lighting. The solution is I think well designed for street lighting projects. And I apologize, I've kind of forgotten the second half of the question, but I'll maybe just take a little bit in this direction. Lighting, in our experience, street lights is a platform, viewed as a platform within the city, right? So it's a place that has electricity. There's a real need around delivering, an IoT solution or, demonstrable ROI for lighting, but it becomes a great scenario to build in other IoT applications. So, people look at, parking or, some sort of traffic monitoring or safety. So all of those things could be, the IoT platform, ThingWorx, could be used to deliver that first solution, but enable you to also, leveraging that same technology set, to deliver the forthcoming application. So I think, I'll definitely will connect some people to that person to explore that conversation. We definitely have experience going down the lighting avenue, and really view it as a good use case for an IoT platform, and particularly ThingWorx, for building out these sort of additional solutions that might leverage the light pole.
Great. Thanks, Scott. So another kind of just a general question. Someone asked about what is the learning curve to master the tool?
That's a great question. Like any piece of software, there is a learning curve, and I think it depends on your background. There are different elements of the tool also. As we described, you could enable business analysts to just be using a portion of the technology, which might have a lower learning curve. But to use the full suite, and typically, I think, which is probably where the person's going, there is a modest learning curve. I'd encourage everyone on the webcast to go to the developer zone on ThingWorx.com to see the software, or encourage someone from your team to try it out to get a feel for what that learning curve might be. And we'd be happy to guide you through the experience as well. So we're happy to have conversations with you. But the ThingWorx, when we look at it modeling, it's an object-oriented model. So if you're familiar with classes, it's going to have a similar feel. So I think the learning curve is what I'll say modest. But I encourage you to get a first-hand view in the developer zone.
Great, thank you. So the last question or two here. Let's see. Can we use any type of gateway independent of the connecting protocol of the thing? Do you help to engineer the proper device edge or connecting application?
So let me try and break this into a few parts here. So one, just to be clear, and I think it was clear to this person, but I just want to be clear. We're providing only the software, right? So there's no hardware coming from PTC or ThingWorx. So we're working with all virtually any gateway. If you use the Edge microserver, you can connect to a device. So depending on the protocol, if it's already communicating, it might connect in very quickly into the Edge microserver running on a gateway. If you seek to embed an SDK into a device, you might have some edge. There would be some scripting at the edge to make that the connection between the device and or some programming to make the SDK work with the device. There's a lot of resources to walk you through doing that to make it as easy as possible. If the device is already communicating via a protocol has some agent communicating off with it, there are other methods that we could leave it as is and communicate, leverage the protocol that it's already communicating at the server side, so introducing, or at the connection server side. So we can establish a translation for that protocol, or put some piece of and I apologize, I'm just blanking on the correct term here, but we can put in a put some piece of what is the correct term here? Well, anyway, we can do the translation at the server side. So I'm not sure I answered that question fully, but I think I at least touched on the major parts of that. So we'll take a look at the write-up after and follow back up if I apologize and we didn't answer it to the fullest there.
Well, that was great. Thanks, Scott. So I think the last quick question that we have before we're at the top of the hour is just, is the platform solution HIPAA compliant so that it can be deployed in healthcare environments?
Let me, and there are other people within the organization who are going to answer this question, and we'll be sure to connect you with those. But for everyone on the phone, I'll take my stab. So the PTC and ThingWorx solutions are deployed in, with almost all of the leading medical device manufacturers, in hospitals, in locations that require HIPAA compliance. So the technology can be used to produce a solution that is HIPAA compliant, and it has been done so in virtually all of the leading medical device manufacturers. So, we're not validating that the platform is HIPAA compliant, what I'm just trying to communicate, but the solutions that companies build with or use along with their devices will be validated for HIPAA compliance by, typically by the company that's bringing it to market.
Great. Thanks very much, Scott. Well, everyone, I think we are now out of time. As I indicated earlier, this session was recorded and will be emailed to all registrants. I'd like to thank our presenter, Scott, for making this such an informative hour, and thank you all, our audience, for participating in today's session. We hope that you found today's event valuable and will return for future webcasts. Thank you, everyone.